Hello friends, continuing with the chapter of atom, today we come to its fourth part, size of nucleus. Now introduction. So far we have discussed about Bohr's atomic model describing stability of atom, in which we have learned that a stable atom possesses two main parts: extranuclear part, in which electrons are revolving around the nucleus, and central nucleus containing positive charge. Bohr's three postulates dealt with the extranuclear part containing electrons, and now we come to learn about the central nucleus containing positive charges. Question rises as to what is the size of the nucleus. On the suggestion of Rutherford, H. Giger and E. Marsden proceeded to determine maximum size of nucleus. They performed same classical experiment of alpha particle scattering using thin gold foil. Second, experimental setup. 5.5 million electron volt helium particles, that is alpha particles, emitted from radioactive bismuth 214 Bi83, having velocity of 1.63 into 10⁻⁷ meter per second were used. These alpha particles were collimated into a narrow beam through lead bricks and were bombarded over a thin gold foil of thickness 2 into 10⁻⁻⁷ meter for scattering to take place. The scattered alpha particles were observed through a particle detector consisting of zinc sulfide screen and a microscope, as shown in diagram. 3. Assumptions made. First, gold foil is very thin. Second, not more than one alpha particle scattering takes place. Number 3, charge on alpha particle is 2e, where E is charge on an electron or proton. Fourth, gold foil remains stationary throughout scattering. Okay. Now fourth step, observations made. The alpha particles on striking screen produced bright flashes or scintillations which could be observed and counted at different angles from the direction of incident beam, and graphs were plotted. The graph of total number of particles scattered n at different angles theta agreed with the calculation of impact parameter B. Here you can see in the diagrams, this is the number of particles scattered n and versus impact parameter B plot, and this is the particles scattered at different angles, and r is the distance of closest approach to the gold foil. Now fifth, calculations made. For the particles retracing its path, whole of its kinetic energy is converted into potential energy at a distance of closest approach. Therefore, kinetic energy is equal to potential energy. That is, when an alpha particle approaches the positively charged nucleus, due to repulsive forces, first it comes to a stop, then it retraces its path. Theta, angle of deflection is 180 degree. Okay. Or we can write 5.5 million electron volts, which is the kinetic energy of alpha particle, that is equal to F dot R. F is the repulsive force and R is the distance of closest approach, which is equal to F into R into cos theta. Because theta is 180 degree, therefore cos 180 is minus 1. So we can write it as minus F into R. Or we can write 5.5 million electron volts is equal to minus K naught ZE into 2E divided by R square, which is the repulsive force between alpha particle and the positively charged nucleus, into R. Or we can write it as minus K naught 2Z E square by R. Now we substitute the values. 5.5 into 10 raised to power 6 into 1.6 into 10 raised to power minus 19 joule. Here we convert 5.5 million electron volts into joule. And for K naught we write 9 into 10 raised to power 9, 2 as it is. For Z we write 79 because Z for gold is 79 into 1.6 into 10 raised to power 19 whole square, it is a charge on a proton, divided by R. Or we can write R is equal to 9 into 10 raised to power 9 into 2 into 79 into 1.6 into 10 raised to power minus 19 square, divided by 5.5 into 10 raised to power 6 into 1.6 into 10 raised to power minus 19 meter. And on simplification we get R equal to 41.3 Fermi. Or we can write it as R equal to 41.3 into 10 raised to power minus 15 meter, which is the distance of closest approach and is the maximum size of gold nucleus. Now sixth, conclusions drawn. The maximum radius of gold nucleus could be 41.3 Fermi. Thus the size of nucleus at the maximum could be of the order of Fermis. So this was the conclusion that was made by Giger and Marsden after the calculations they made on the basis of experiment done by them. Assignment 12 continued. Question number 15. What is the distance of closest approach of an alpha particle to the gold nucleus which undergoes scattering by 180 degree in the Giger and Marsden's experiment? Thank you so much. Next time we will take up next part of it. Till then, goodbye and good luck.